Sylvia, I was just reading about how the moon's back in the spotlight, but it's not the same old story from the Apollo days. This time, the South Pole's stealing the show. What's driving this lunar comeback?
Albert, it's not just a comeback, it's more like a lunar gold rush. The South Pole is the solar system's hottest piece of real estate right now. Forget those sunny equatorial plains where Apollo astronauts planted their flags in 1969. Everyone's eyes are locked on those permanently shadowed craters near the South Pole. Why? Because they're hiding something game-changing. Water ice.
Water ice? Well, Sylvia, we live on a planet where 2/3 of the surface is covered with water. Why would we go all the way to the moon for it?
Good question. On Earth, water is everywhere and cheap. But in space, it's priceless. First, sure, you can drink it and grow food with it, which is critical if astronauts are going to live on the moon for months. But here's the real game changer. Water can be split into hydrogen and oxygen. That's rocket fuel, Albert. Imagine if rockets heading to Mars could refuel on the moon instead of carrying all that weight from Earth. Launching fuel from Earth's deep gravity well costs a fortune, but producing it locally on the moon could slash costs and open the door to deep space travel.
What? The moon could actually turn into a kind of cosmic gas station? That's wild. I mean, just think about it. Refueling spaceships out there, using lunar resources, it sounds like something straight out of a fairy tale. Honestly, that's pure utopia for me.
The South Pole of Moon has another advantage: the peaks of eternal light. Some ridges there are almost constantly illuminated by the sun, perfect for solar power. So you've got two essentials in the same place: energy from sunlight and resources like water ice in the shadows.
So that's why everyone's suddenly obsessed with the South Pole, huh? A perfect candidate for a base? Sure, that's what they say, but I don't buy that. For me, it's just about science or exploration. There's more going on here, isn't there?
Spot on. Albert, you're finally looking at the bigger picture. It's not just science. This is strategy. Whoever controls the South Pole controls the resources, and in space, resources mean power. Water ice is for rocket fuel. It's basically the new oil. Countries and private companies all want a slice of that future economy. Because the first one to build a base there doesn't just plant a flag, they set the rules for the next era of space exploration.
That sounds intense. Politics on the moon, huh? Who is now competing in this new race?
Oh, Albert, it's crowded. This is Space Race 2.0. But this time it's not just flags. It's infrastructure, resources, and influence.
Okay, and who's making the biggest moves?
First, NASA. Their Artemis program is aiming to land astronauts near the South Pole later this decade with Artemis III. And their goal isn't just a short visit. They want a long-term presence.
So America's back on the moon. But this time, they're not just taking photos.
Exactly. This time the plan is build, stay, and use resources.
And I'm guessing China isn't going to sit quietly and watch.
Not even for a second. China has Chang'e 7 planned around 2026. And that mission is focused on the South Pole region too. They're scouting terrain, searching for resources, and building a long-term roadmap.
So, both USA and China are basically targeting the same high-value location of the moon.
Perfectly said, Albert. Same target, same reason. But what makes this really serious is that both the US and China aren't just chasing a landing. They're chasing a long-term foothold. The US, through NASA's Artemis program, is pushing toward astronauts and infrastructure, not just to visit the South Pole, but to build systems, power, mobility, and eventually using lunar resources. Artemis III is basically the first big human step toward that future. And China's program is just as strategic. Missions like Chang'e 7 aren't just science tours. They're designed to scout the region, study the South Pole environment, and identify where resources like water ice might actually be usable. Because before you build a base, you first have to map the terrain, test the technology, and choose the best locations. So Albert, this isn't a race to plant a flag. It's a race to secure the best base location on the moon.
So the US and China are basically doing early booking for the moon's best property, the best spot before anyone else, even before the first permanent base is even built. But tell me, Sylvia, where does Russia fit into all this? Are they still a serious player in this new lunar race?
Russia is absolutely still in the game, but now it's playing a different strategy. Instead of leading alone, Russia is teaming up with China on something called the International Lunar Research Station, or ILRS, a long-term lunar base concept that could be built on the moon's surface or in lunar orbit. And this isn't just a rumor, Albert. China and Russia officially signed a government-level memorandum of understanding on March 9, 2021, to cooperate on building ILRS. After that, they even released a roadmap and partnership guide, basically inviting other countries to join. So now it's not just countries racing, it's space blocks forming, NASA leading the Artemis coalition, and China and Russia pushing ILRS as their alternative vision for the moon.
Wow. So Earth politics is literally going lunar. It's like the moon is becoming a new chessboard.
Exactly. Space is becoming geopolitics with rockets.
And India? They've been making headlines. I mean, the news of Chandrayaan-3 was everywhere. Was that just a one-time win? Or is India now a serious player in this South Pole game?
Oh, India is absolutely a serious player now. In August 2023, India's Chandrayaan-3 made a historic soft landing at a high-latitude site near the moon's south pole, making India the first country to land in that near-polar region successfully. And what made it so important wasn't just the landing. It was what came after. If you heard about Chandrayaan-3, I guess you heard about the Pragyan rover as well. Right, Albert? The Pragyan rover rolled out and performed real surface science, including detecting sulfur and other elements in the lunar soil. That kind of data helps scientists understand what the moon's surface is made of, and how usable it could be for future missions. Now, building on that momentum, India is preparing Chandrayaan-4, a mission planned to take India into the next big league, lunar sample return technology. And sample return is a huge deal, Albert, because it means you're mastering the kind of precision operations needed for the future: landing, collecting material, launching back from the moon, and bringing it home safely. So Chandrayaan-3 wasn't just a headline. It was India announcing to the world, we can land here too, and we're coming back with bigger ambitions.
And Japan, Europe, where do they fit into this whole South Pole race?
They're deeply involved, Albert, just in a slightly different style. Japan and Europe aren't always grabbing headlines like the US and China, but they're building some of the most critical technology for the next era of lunar exploration. Take Japan, for example. JAXA has already demonstrated advanced landing technology with its SLIM mission, which successfully landed on the moon in January 2024, and aimed for high-precision pinpoint landing. That kind of accuracy is essential if you want to land near tricky terrain like polar craters and ridges. And Japan isn't working alone. They're tightly linked to the US-led Artemis effort. Japan and NASA have formal cooperation for the Gateway Lunar Space Station, including contributions toward the International Habitation Module, IHAB, basically where astronauts would live and work during future lunar missions. Now, Europe is also a powerhouse here. The European Space Agency is supplying the European Service Module for NASA's Orion spacecraft. It's literally the part that provides propulsion, power, and life support resources for Artemis missions. And Europe is even building future infrastructure around the moon. ESA's Moonlight program aims to create lunar communications and navigation services, like a GPS and communications network for the moon. Because if dozens of nations and companies are going to operate there, you need an actual lunar network. So Albert, Japan, and Europe show us something important. This is a global competition, but also a global network of partnerships. And the countries who build the best technology may end up shaping the moon's future just as much as the ones who land first.
So what started as a space race in the 1960s is now turning into the start of a whole lunar economy. Back then, it was about planting a flag. This time, it's about building infrastructure, tapping resources, and making the moon a stepping stone for the next giant leap, Mars and beyond.
Perfectly put, Albert. The South Pole isn't just a destination anymore. It's the gateway. And whoever builds there first could shape humanity's future in space.
That gives me chills. I guess we'll have to wait and see whether the moon's South Pole really becomes humanity's first space hub, or if we're still dreaming too big. But one thing is still crazy to me. Apollo never went anywhere near this place. So how are we suddenly able to land there now?
Great question, Albert. Let's break it down in another episode of SciTech Talkies, the tech revolution that made the South Pole possible. Till then, take care, and goodbye.